I cut the wires and I put my voltmeter and my probe tester, I should be able to see that I have 12 volts or positive or ground. And then you know the pump's definitely bad.
We said from the beginning of this class, of this program, that the electrical part is the most important part. Believe me, each time, you can repeat this class 5 times and you find productive the class again and again and again because they, no, Jolly?
Once you understand it, it'll all come together. The more you do it, the more you understand.
And every day is more information. In 2 weeks, we are going to start AC. If you have clear the concept of DC, AC is easy. If not, you are confused completely. For that reason, ask the question. At the end of the class, Mr. Rodriguez, Mr. Glenn, me, we are ready to explain again. You can send a text message and ask questions. All right, my friends? Because every day is more information. AC current is a little more complicated. There are a lot of concepts. Okay?
Learn the colors of the wires.
Colors of
The
the
colors.
Not everything's red and black.
No. All right. Okay, and it's different if the boat is European or if the boat is American boat. And it's too complicated if you try to use your European boat in the United States and some Mickey Mouse technician flip cables and connect this with this to power the boat. No, doctor. You need to be clear with the concepts. Okay, guys? Ready? Okay, we are going to start the DC panel. Everybody follow me? That's the DC panel. That's the ammeter, the voltmeter, the main breaker, and small breakers. In some cases, we don't have main breaker. If the panel is small, enter directly in the positive bus bar. This is the positive bus bar. This is the negative bus bar, Lisa, and this is the ground bus bar. The ground bus bar. Some people say this is the same. No. This is the negative and this is ground. Good?
So it's commonly known that the black one is the ground. So in
Black or
this case-
yellow?
Yeah, so in this case, the green is the ground. So
No.
Green is ground.
Green is ground. But
Negative.
It's more for the bond.
So
Black
you
or
have-
yellow is negative, is the return. The people say on the street, this is the ground, but it's not
The red
ground.
and the black is in the circle.
It's in the circle, correct. And
And yellow too.
and from the body is the ground. Imagine all the time that you need to connect the body of the equipment to the ground bus bar. For what reason? To drain static electricity.
Because if you don't drain that static electricity, you get hurt, and then only that, it'll corrode the housing completely because the moisture and it's got constant power, it's going to heat up. When you ever seen a battery go underwater, what's the post that gets eaten up quick?
Positive.
Sure? Positive. Positive gets wiped out. And that's what happens. So you have a positive housing because it's not being drained, it'll eat that housing.
I have a couple of ABYC questions. The red cable is grounding conductor or ungrounded conductor?
Ungrounded.
Ground, excuse me? Is ungrounded or grounding?
Ungrounded.
Ungrounded. And this? Grounded. Ready? Right? Okay, good. We are going to start. We have 2 battery banks. Battery bank number 1, battery bank number 2. We have the battery switch selector. We have the a.c.r. We have the panel. We have a couple of equipments, 2 or 3 equipment. In this case, we have a blower. We have light. We have a horn. No?
Yeah.
Danny, we have a horn.
Yeah, Brandon knows how to troubleshoot that now.
We have a horn. And also we have a okay, and in this side we have the engines, we have the batteries, we have the instruments, we are going to connect in the second part this. Okay, now this is the first element. Okay, the a.c.r. The a.c.r. The a.c.r receive power from the battery switch, no? Yes or not?
Yes.
We are going to do this. At the end of the day, we are going to do the wiring completely of the boat. The DC panel, the AC panel, the electronics panel, and the dashboard. That's clear, my friends? We are going to do this. Ready? Okay.
Not only by doing that, when you look into a service manual, look at the schematics, you'll understand it a little bit better.
Look, from positive number one, and also in the position number one. And here from position number 2, I go here and also from the a.c.r. The a.c.r. have 2 inputs, and in this particular case 3 outputs. One of the input for this particular case is from the battery charger. You remember the battery charger? This is the battery charger. What is the input of the battery charger? What is the input of the battery charger? Guys,
AC.
AC power coming from
shore.
from the shore power or the AC panel. That's the next project. That's correct? This is AC power. And this is the output is DC. And the DC one enter here. The other one, the other source of power in this boat is from the alternator, positive output. You remember? Normally that color is
purple.
orange.
Orange. Sorry, my fault.
Ready?
That's the alternator, the big circle.
The output of the alternator enter here in the a.c.r. And from those outputs, you feed position 1 and position 2. And right now the a.c.r. is connected. You have a question about the a.c.r.? This is the a.c.r. Automatic charging relay. The input is the source of power. One source of power is, guys, the battery charger. And the other source of power is the alternator. Can I feed both inputs from 2 alternators? Yes. Here we are going to do that. We have 2 engines, 2 alternators, and we are going to feed both of them from the alternators later.
Can you put more than one on the post?
In this particular example, I have one here for this. I have another one here for this.
So like, let's say you hook up a battery charger to that one, you go hook it up to like the same post as all 2?
No. In each terminal, only one source of power. Good? Until this point? Questions? All right. Now,
The one going to the battery charger, what color is it?
excuse me?
The one from the a.c.r. to the battery charger, what color is the wire?
Those, it's red normally. It's red. I put in different color only for. It's red or orange.
Can you just make it like orange to say that's the charging?
Usually it's orange.
All right.
At least most of the time on the work.
So most of the time, from the battery charger, from the a.c.r., the wire is orange or red.
Well, on the a.c.r., I mean from the battery charger, it's usually red or black.
Red or black.
Red or black for the ground, and red is for on the charging side. On the alternator, it's usually orange.
My friends, follow me. This.
The a.c.r. charging the battery.
The a.c.r., the only purpose of the a.c.r. is to balance the charge of the batteries.
The level of
Or
charge.
the batteries.
Originally, you said, okay, you said there's 2 ins and 3 outs. The ins are the black, right?
The ins are those. and those are the outputs.
So, okay.
And
But I was looking at it, I was thinking there was 4 in, but no, okay.
no, it's 2 and 3. Normally it's 1 input, 2 outputs. 2 inputs, 3 outputs. 4 inputs, 5 outputs. Yeah. Everybody follow me? I have one free. Oh, you can use that one for other battery bank, if you have another battery bank. This a.c.r work for 3 battery banks. I am going to use this one only for 2 battery banks. The other one will be available in the future.
If you have like, you can have a separate a.c.r if you have like solar chargers and then connect it to.
Correct. Pay attention. Great question. Look at this. No, in this particular case, the source of power, I have 2 sources of power. Suppose that I don't have this. I have
Solar panels.
solar panels. Okay. The solar panels are connected in parallel. This is the negative, and from the positive of both solars, I bring the charge for this. One source of power is the solar panels. Other source of power is the alternator. In that boat, I don't have battery charger. It's a sailboat, for example. You like it?
So if you got a generator, how would, would that?
Oh, the generator is here.
Well,
The generator is-
the charger.
Steve,
Okay.
the generator is a source of AC.
Okay, right.
It later.
You can
Okay.
have a windmill too.
Oh, suppose that you don't want this one. You don't want alternator. You want solar panel and windmill. Okay. The windmill here have a small alternator, and the alternator produce positive and negative, and I have windmill and solar panels for the source of power. You like it?
So if you wanted to use the generator, you would have 3 inputs and 4 terminals out.
Yeah, but the generator is not considered a source of DC.
Just turns on.
It's considered a source of AC. That's different. That's different. The generator,
Okay, the generator will only activate the charger. It won't
the
charge.
generator will be good to bring power for the battery charger. This is in case of the hybrid boat. What is the hybrid boat? The hybrid boat is an electric boat or electric car with electric AC motor and batteries. When the level of batteries decrease 20%, and a small generator start automatically, send power for a battery charger, and the battery charger charge the level of charge in the battery bank until 100%. When the battery bank is 100%, the generator stop, no more battery charger, and you continue driving. Oh, once again, the level of battery decrease 20%, the generator start again, supply power for the battery charger, and the battery charger charge the battery bank. This is a hybrid car, a hybrid boat. What is the advantage of the hybrid? That you don't need a stop in Port St. Lucie to connect 1 hour and stop again in North Carolina and stop again. No, the generator start and stop each 45 minutes, start for 10 minutes, recharge the battery bank, and you continue driving. You like it? This is hybrid. What is better, hybrid or fully electric? Hybrid. If in fully electric, you need 1 hour.
I think eventually we'll get there, but not anytime soon.
Well, does the generator power anything else besides the battery charger?
Yeah, but we are going to talk later about that. Okay, now this is, we are going to continue with the panel. This is the battery switch selector. 1 input from battery bank number 1, 1 input from battery bank number 2. At the same time, both battery banks are controlled for the a.c.r. The a.c.r receives 2 sources of power and keep the level of charge in both batteries
Equal.
Okay, now in the output. In the output, I am going to create 2 cables. One cable with a constant positive bus bar. This is constant positive bus bar. For what? for bilge pumps, for PV, for, yeah, constant power. And other one for, and, sorry, this is not here. I make a mistake. Sorry.
True one.
Okay, this is for cranking purposes. And this one is for the panel. And now I am going to install here the fuse. And after the fuse, I am going to install, what is this? The shunt. Pay attention. On top of the shunt, from top of the shunt, enter into the main breaker if you have main breaker, and after that enter into the positive bus bar. If you don't have main breaker, in your project you don't have main breaker, you enter directly here. Ready? In other boats you have main breaker. You interrupt here with the main breaker.
The fuse isn't the, oh, so you have a fuse and a breaker? Because first it goes through a fuse, and then a shunt, and then a breaker.
And then the breaker.
Yes.
Do you need the fuse and the breaker?
Correct.
Yes.
Correct.
The shunt's really, the only purpose of that shunt is for the ammeter.
It's for the ammeter.
Oh, but the breaker, the
The main breaker is to
fuse,
protect the whole system.
The fuse,
That fuse protects the system completely.
and so does the breaker. It's redundant.
Yeah, it's
Both of them.
only because it has the ammeter. If it didn't have the ammeter.
This is for protect. It's for
Oh,
safety.
okay, so the fuse goes with the shunt,
If it has an ammeter.
if it has an ammeter.
If you have an ammeter and the panel is a small panel.
It's
Okay.
small.
So this is what she's asking, if you did not have the shunt, do you need the fuse?
Yes.
Right? That's what you're
You
asking.
still need the fuse.
You still need the fuse, even though you have a,
Main
Yeah, what
circuit.
happens is that main fuse will protect the electrical panel from catching fire. It'll just touch the whole source to everything.
okay.
If that blows, there's a major malfunction.
So if that first fuse blows, you know you'll own that none of, everything else won't work on your panel except that one system.
Okay.
And like you said if the panel is small and has no ammeter,
Yeah,
you don't need a
smaller
shunt.
panels. Even if it's a big panel or a small panel, if it doesn't have an ammeter, you need a fuse no matter what.
But no shunt.
No
Okay.
shut, only for the small panels with the ammeter.
And because
Okay.
it's coming from the main battery source, that is the main difference, why you, right? Is that the main
Yeah,
reason?
but
why
let me
you-
Just think
explain
about your
something.
house. You know how your house, you have a main breaker that cuts the whole part? That's what that is.
You need ammeter and voltmeter. Always. And you need more than one ammeter and more than one voltmeter. I'm going to explain right now.
It's important.
Why you need ammeter and voltmeter?
The reason, so
Excuse me?
you can maintain battery levels, so you don't kill your batteries.
You want to know how much is the consumption in amps, especially in a boat. Pay attention to this. Suppose that I live in a small sailboat, only with one battery bank, and the capacity of that battery bank is 400 amps. It's a small sailboat, 400 amps. The life in the boat depends on the battery bank. No? You need constantly check the voltmeter in order to verify the voltage of my battery bank. How much should be the voltage minimum to consider that the battery bank is fully charged? 12.5. Less than 12.5, you have 85%, 90%, 75%. Yeah? Remember the table in the book? Okay. 12.5 is the magic number. And you need verify periodically the ammeter. Hey, when I connect the freshwater pump, the consumption is 30 amps. 30 amps. That's normal? In a freshwater pump, normally maximum 10 amps.
10, 15,
It's,
depending on the size.
it's 10. 7 amps. 30 amps is too much. If I continue using in this sailboat the freshwater pump, I drain the batteries. The ammeter is very important. The ammeter is more important than the voltmeter.
Just like the engineers in the boat, they're constantly monitoring the
Correct.
amps.
So the ammeter would be like your gas fuel gauge, right?
Correct. The ammeter is the same than the flow meter in the fuel tank. How many gallons per hour is the consumption of the? Oh, wow, 10 gallons is too much, no? In a boat, you need flow meter for fuel. You need flow meter for fresh water. You need flow meter for all the element. When you have a flow, in this case is a flow of electrons. You need an ammeter. Right? That's clear? All right. Now I have power in the
Positive bus bar.
positive bus bar. Okay, I am going to feed the blower. The blower have one. Where is connected that one? Here, and this one is connected to ladder. Not here, not here. Ladder is connected to the ground. Right? And this is ground. At the end, this is the bonding. This one is the bonding. Look, this is the bonding conductor, and the bonding conductor at the end is connected with the piece of zinc. Later this one will be connected here with the bonding. But don't confuse right now with that. Forget that. Erase it.
Yeah, what question you have?
All right. Okay.
They have a couple questions over
No, later.
What was that for? What was that for? Why did you already have a...
Later.
Oh, okay, I see what it is.
Yeah.
Okay.
I'm glad you reached.
Okay. Okay. Until this point is clear? Excuse me. Yeah?
So the zinc, you have to connect it with like a battery cable? Or like
No.
wire?
We are going to talk later. Okay, the blower. This breaker, the number one will be for blower. Okay. The positive cable of the blower is going into the output of the breaker. Yes or not?
Yes.
Ready? Additionally, you remember that at the end of each breaker, you have an LED. What about the LED for that breaker?
The output.
One terminal is ground, and the other one is connected here to the output of the breaker, and the light will be on only when you activate the breaker. When the breaker is off, the light is off. Never connect this one here.
Never connect.
Anybody follow me?
Which one?
If we found that in your project all the lights on with everything off, it's because you put those elements here.
And now it'll cut all your wires.
Yeah, and your head with a hammer.
Oh wow.
Say that again, what was wrong?
Normally the people, this is the LED. The people put this one to the ground and the other one to the constant positive bus bar, not to the output of the breaker.
Oh, okay.
Okay, right?
Alright.
Question about if you have not the 30 amp ammeter, you have a bigger panel, you just go straight to the ammeter, and from the output of ammeter goes to the main breaker, right?
Yeah. But let me, we are going to connect this one right now. The ammeter should be properly connected to read everything, not one specific element. Right now we are going to do that. Okay, great. We are going to connect the light. What is the procedure? Ground here. No? And the positive, where is the positive?
Output.
The positive to the second breaker. And the light the same, bam, bam. What about the horn?
Third breaker.
Exactly the same, no? Breaker number?
3.
And ba, 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 ba. If you have more equipment, you connect more. Difficult?
No.
That's too simple, no?
Starting to come together.
Come on, paper.
It'll really come together when you wire your panels.
You're doing that today?
Well, today you guys are gonna be tearing them apart. So you're gonna make your groups, so whatever groups you guys make, then you're gonna use the same group. But whatever panel you're tearing apart, you're not putting that panel back together. You're gonna put the other one, whoever tore the other one apart.
So the grounds that are on each of these devices that just...
Oh, this one. Excuse me. What is the ground here? To that one. What is that one? No. If this light is in a holder, if this light is in a metallic holder, the metallic holder is, and this is from the ground, from the case of the horn
And the black one goes to the negative.
to the
bus bar,
negative bus bar,
Which the negative battery.
which goes
to the negative of the battery, correct,
Which all is together.
correct. You like it?
Yes.
Right. Oh,
The majority of the marine DC, follow me, listen to me, my friends. The majority of the marine DC equipment, they don't have green cable because they are considered ignition protected. The rotor and the stator is completely sealed, and they promise 200% sure that no electron jumped into the case.
The green wire only goes to metal, not to like a build pump or plastic.
Oh.
Only the metal only.
Only the metal, only the case.
green only goes.
For example, my friends, I have a battery charger, and the case of the battery charger is metallic. The case of the battery charger should be connected to what bar? To the green bar. The case.
The bonding.
Yeah?
But that's different.
That's correct. If the case of the equipment is metallic, the case should be connected to the metallic. Excuse me?
Will most like components have like a terminal set aside for bonding, with like a screw or something?
No, you'll make your own bonding system. And we'll go more in that in detail in the ADC.
Yeah, but this is later.
Tyler had a question. Tyler, what question you had?
So the green one just connects to the negative.
The green is always connected to the negative, but it's
On the DC panel?
on no, the green, yeah, if it has the bar for it, yes. There's different panels, different styles of panels, so it's important to understand what panel you're working with. So when you order a panel, you order the same panel. If not, if you order one without the bonding system, then you'll have to make a separate bonding system outside the panel.
Green wire.
You guys don't realize how important that bonding system is. It'll eat everything that's in the water.
Let me tell to you something, my friend. Pay attention. Some people say, Mr. Lopez, you are too complicated. When I put my negative cable to this one, my pump works, my light works. Yes, papi. But that green is the lighting, is the bonding protection. Pay attention. During the storm, during the hurricanes, you have at the end of the mast a piece of rod, of metal, and that metal is connected with a green cable connected to the bonding conductor and the sink. In the moment of a lightning, how much is the voltage of each lightning strike? It's 12,000 millions of volts. That amount of current goes directly to the bonding conductor and goes out. What happens if one Mickey Mouse technician connect the bilge pump not to this one, the negative, to this one? What happened with the bilge pumps? Explode in the moment of the storm. It's different. The ground cable, the grounding cable, and the negative. Now you understand? In the grounding cable, you have connected for emergency all the lighting protection elements in your boat. In the moment of the storm, you have big currents flowing. If you connect equipment to that element using the negative, that element for negative, you explode those elements. Okay? Be careful with that. But later we are going to talk about, because I know that you have a lot of questions about that, but this is later.
Not only that, it protects you because if it doesn't have a ground, or like a device doesn't have a ground, you'll be the ground.
Correct? You are the ground.
Yeah, remember, electricity is always looking for the quickest source to ground.
Okay, great. Until this point, you like it? Good? How many sources of DC power you have? Solar, windmill, alternators, battery chargers. Great? Okay. Now, we are going to connect the rest of the equipments. We are going to connect the star motors. We are going to connect the relays, the battery switches, other a.c.r, the oil pressure gauge, temperature gauge, fuel gauge, tachometer, alternator, and ignition switch. Ready? Okay, the ignition switch. The ignition switch receives the power from from constant positive bus bar. Pay attention. Look at this. This is a boat with how many engines? Two engines. Two inboard engines. Each engine have your own battery bank or group of batteries. Battery bank for starboard engine and battery bank for port engine. Good? What is the secret? One battery bank, other battery bank. The negative should be connected. The negative should be together and connected with the main negative bus bar. Connected with this. All the negatives connected together. Ready? Ready, my friends? Okay. Look at this. I have a positive bus bar. I have a positive bus bar connected directly from the positive of one of the batteries in the house. In the house. Why? Why in the house? Look at this. I want to connect the ignition switch. Where is located the ignition switch in a boat? Where? In the pilot hand, no? And that ignition switch receives power from what group of batteries?
Cranking.
Cranking?
Cranking.
Or house? House. Ah, okay. This is house. Yes or no?
Yes.
Okay. From one of those batteries, this is the house batteries, directly from the positive, I create a constant positive bus bar. Is clear? And from the constant positive bus bar, I feed the terminal battery in my ignition switch. Good? Okay, and now I have the purple ignition. Suppose that this is purple ignition. And the other one is? The other one is? Star. What is the color for a star? Yellow, red. Yellow, red. Okay, great. I am going to crank the engines. Crank the engines. Pay attention. I have two battery banks. This is a little complicated. Pay attention. I have two battery banks. One battery bank for this engine, other battery bank for the second engine. In your project, we only have one engine. Correct? Not two engines. I am going to make the drawing for two engines only for your information, because in the future you need to connect two engines. But in your project, you only have one start motor and one ignition switch. It's okay? All right. Look, you have two engines, and you have two start motors, and you have two alternators, like in your boat, Lisa. Two engines, two alternators, two start motors, two battery banks separated. And you have two switch selectors. What is the idea with those two switch selectors and two battery banks? That you can combine both batteries to start one engine, or two batteries to start both engines at the same time, or start each engine separated. I'm going to explain the procedure to connect both battery switch selectors to do that procedure. What is the recommendation when you have two engines in a boat? Start both engines at the same time? No. Start one engine, run the engine for a couple of minutes until the engine produces power. How the engine produces power? The alternator. And after that, start the second engine. Okay? All right. We are going to start this engine. This engine. Remember that the solenoid, guys, remember that the solenoid have one big positive entering here, and the big positive pass through the other big positive. Only if you bring the signal yellow, red here. That's clear? Everybody follow me? The big positive enter in the winding of the motor only if you bring the yellow, red. Yes or not?
Yes.
Okay. I am going to bring the big positive. Okay, this is battery 1, battery 2, all right. Look, battery 1 and at the same time battery 1 is here. Battery 2 enter in position number 2, and at the same time enter here. That's clear? With the a.c.r? And where are the inputs of the a.c.r? Look at this. Alternator number 1 and alternator number 2. What cable in the alternator?
Orange.
The positive output. You remember? Positive DC output. What color should be this and this? Orange. Orange. And now I have an a.c.r working to keep both battery banks equally charged. Nice, no? This is in your boat and your boat. That's the situation. Great? Okay. But I want to start the engine. I want to crank the engine. To crank the engine, I need bring big positive here and yellow red. Okay. All right, the big positive is coming from the relay. What is the name of this? Crank relay. Crank relay. Nice. And what is this? Start solenoid. That's different, no? One is a solenoid with, and the other one is relay only passing the current. That relay receives the power, the big power from ignition switch, big power, from this one. You follow me? From switch selector number 1. The second one. That's clear?
Yes.
For the other engine. We are going to do one engine, the other one is the same. And that relay open and close depending of a signal coming from ignition switch. What color? What color?
Purple.
And the other terminal here is and what about this?
Yellow red.
This is for the solenoid of the start motor. Bingo! My engine is cranking. But pay attention. Pay attention. In this moment, this switch selector is exclusive for this engine, and this switch selector is exclusive for that engine. What happens if you are using the boat in this moment in Alaska? In the morning in Alaska, you need more power or less power?
More.
A lot. What is the idea? Start engine, one engine, and after that the second one. When I start this engine, I want to use this group of batteries plus this one, both of them at the same time. Yes or not?
Yes.
For that reason, internally in the back of the switch selectors, I am going to connect with other cable, big one, like this, position 1 with 1 and 2 with 2. Internally. You follow me? 1 with 1 and 2 with 2. And now you can work with both batteries at the same time. You like it?
Yes.
If you put both switches in parallel, you use both batteries. And you start this engine. Okay, it's running. Now start this one. It's running. Good? Your brain is melted?
El switch no tiene protección. The switch doesn't have protection.
That one?
Yeah.
Yeah.
Is that done through just a fuse, or is that done through
It's
a
a fuse.
breaker? Or
It's a
just
fuse.
just a fuse?
Normally it's the fuse with the red button, you remember?
Yeah.
With the red button, the big one.
Okay.
But usually that's on the motor.
Danny can show that
That's
one.
on the motor.
You enjoy the class, my friends?
Yeah.
Complicated? This is the simple part of this class. After that is more and more and more. Believe me, you need follow, take your notes, create a folder with that information.
If this is any foundation, this is probably your most important foundation. Yeah.
So for the second motor, you just want another purple wire?
For the other one? Yes, papi. You have another one here. This is ignition, pam pam. This is from the other positive bus bar here, from the other positive bus bar, and this one for this. Yeah, it's exactly the same because you have two ignition switch, one for starboard engine and other for port engine.
And the reason you have it isolated, so if you have a problem with the engine, it doesn't take the other engine out. Every time you have two
You have
engines,
that picture
isolate.
here.
You gotta isolate the engines, isolate the bolt stuff from the motors, so if there's a malfunction, it doesn't take everything out. It's a redundant system, really.
So if you're in Alaska and you gotta start the boat, you put them on, the switches on off, on both. So
Correct.
now you're using both banks. Once you're up and running, the motor's warm,
You
you have to
return,
turn them back.
you return to position 1 and position 2.
If you don't, and let's just say you leave them on all, and then you go wherever, and somebody leaves the lights on, whatever, you're gonna have all dead batteries.
That's correct.
Okay, so if you leave them on
You
one
hear?
on one, one on two, and you go to a restaurant, whatever, and you leave a light on, you're only gonna have one bank of dead batteries. Then the only thing you have to do
That's correct.
is
That's,
put them on all, start your boat and go.
that's correct.
If you leave them on all, you're gonna have all dead batteries.
You have that problem in your boat?
Oh, I had that problem.
Talking from experience.
People think,
You hear the explanation of Glenn?
Probably a couple times.
people
You
really think
also?
putting it on all is better, it's not. For starting purposes, it's good.
My friend, you like it? You understand that connection? It's nice, no?
And there's one more thing, just like with the bilge pump, you designate one battery for your bilge system. So that way, if let's say, God forbid, the battery's dead, there's a lot of water, you put the battery switch on all, it starts pumping. You use both batteries, and now you have two dead batteries.
You can't have one ignition switch with the ignition bus bar?
You could, but what happens if there's a short, now you just took out the other engine. Isolation. This motor's independent from that motor's independent from the other, and all your boat stuff is independent from the two motors.
So it's common to have two ignition switches?
Absolutely. Now the new motors today have one ignition switch, but they have push button starts. So you start one engine, you start the second engine.
You're
But it's
gonna
still
find most
isolated.
motors
The thing is,
leave that
you walk
switch
around with
on
two
all,
keys, three
but
keys.
you gotta find it.
Yeah.
Well, yeah, you had two, three, like a day. Very possible.
Yeah.
Over there where he has the other ignition switch, does he have that's a positive bus bar on the top?
Yeah, it's another positive bus bar.
This is the project that we are going to do right
How
now.
would you do the connection with the push button start?
Well, the push button start would have, it's actually like, it'll have basically the purple would excite when as soon as you turn the key, you would have it, and then when you press it, it would actually transfer it would have the purple constantly on the motor, because as soon as you turn on the switch, it would turn both engines on. But to start, you're manipulating the yellow with a red stripe.
So-
And then what happens is when you want to turn it off, you hit the button the opposite way. What it does is cut the power from the purple, so that way the computer shuts down. See, not every boat's rigged like this, but this is, on the big boats, it's gonna be like that. Yeah. My size, the boat's a little bit different. But this is pretty much all the same in the sense.
Just so I'm sure I got that So in that purple cable, you just add a button in between it, right? Like,
For the purple for the ignition. Yeah, the purple with the ignition. If you
no, I meant that button, the push start would be on the yellow red, right?
it would be on the yellow red, but it would also have the purple. That's for the newer boats.
The yellow red is exclusive for the solenoid of the
Well, I was
starboard.
asking if you have like the push button start.
Yeah, the
Okay,
push
so-
button.
The
start
push
with-
button?
Yeah.
In some boats,
Yeah, what happens is it'll just take the yellow red stripe off the switch and go right to the push buttons.
let me explain
But it
something.
has to have the purple constant power and the yellow.
This is the first big diagram in this program, the DC. We are going to do other bigger than this for AC. After that, we are going to do the wiring diagram of the harness of a diesel engine or gas engine. The harness completely with all the sensors. And after that, we are going to do the wiring diagram in a board like this for the air conditioned equipment.
Wiring so.
Keep your pencil different color for the rest of the life, okay? Because we are going to do a lot of wiring diagram.
Well, anytime you're gonna wire a boat, you want to kind of draw it out to have a general idea where you want to do it, and you have something. But even though you draw it out, you might not implement that completely in your boat because you might modify because
Yeah,
you
yeah.
anticipate certain
Yes,
things.
is there a CAD
It's always good to have
program
the
we can
drawings.
use to,
And
is there a free one?
for,
There is a
here
couple
is
free ones.
in AutoCAD.
Well, AutoCAD's super expensive.
Yeah, I know.
Oh, is there-
No,
There's
it's
a
another
couple
one.
free
It's-
one. There's a
There's
couple
a free
free
one?
ones.
Yeah.
I got a.
You have that one?
No.
If not, Diego have other one for
No,
you.
no, we have a list of the free auto, like the drawing.
Mhm.
There's like 2 or 3. I know I used 2 of them. I can't remember, it's been a while.
I remember I did the course for AutoCAD some years ago, 200 years ago.
Yeah, I'm gonna start doing that.
You. All right,
Gotta get into that sort of design.
but I prefer my AutoCAD. Guys, now we are going to connect the gauge. Oil pressure gauge.
That's different.
Okay, guys, look. Now we are going to connect. This is the oil pressure gauge. Look, the oil enter at high pressure from the oil pump of the engine here, and this is the cable with the signal for the gauge. But let me tell to you something about in your boat in the next coming days. In the summer, we are going to take gasoline classes and diesel classes. There are switches and sensors. For example, in your engine, you have a couple of switches and sensors that create a lot of mistakes, problems. For example, in your engine, you have oil temperature switch and oil temperature sensor. And you have oil pressure switch and oil pressure sensor. Who is familiarized with engines, gas or diesel? The rest of the people know? Not too much?
Not too much.
Okay, look at this. Where do you think that the oil temperature sensor and the oil temperature switch are located? Temperature. For the engine. In what part of the engine of the block you think that is located the oil temperature switch and the oil temperature sensor? Excuse me?
Or would it be the mid section because temperature, right?
In the thermostat housing. You know that the engine have a thermostat? When the thermostat is open, the coolant circulates in between the radiator and the engine. When the thermostat is closed, the coolant stays in the block until the temperature rises. After that, when the temperature is in the limit, what happens with the thermostat? Open and the flow continue, go to the radiator and return. Yes or not?
Yep.
The element where the thermostat is located is called thermostat housing. Okay, in the thermostat housing you have oil excuse me, coolant temperature sensor and coolant temperature switch. Okay, pay attention. The sensor have one cable connected with the temperature gauge, the sensor. And the switch is a normally closed switch. The purple cable enter over there and continue because it's normally closed if the temperature is. When the temperature pass the limit, what happened with the temperature switch? Open and interrupt the purple cable. What happened in the engine if the purple cable is interrupted? Kill. Finito. And stop the engine. In other words, the switch is used to interrupt, to kill. And the sensor is used to send the signal for the gauge. It's clear, my friends? In the future, when you hear, oh, the sensor is damaged, it's the element that sends the signal to the gauge and also to the computer. Signal, the sensor. The engine is running and stops suddenly. I start and start again. What is the problem? On the sensor or on the switch? On the switch. You need to verify which switch is the switch that interrupts. How many switches in the harness normally in a typical engine you have? One for oil pressure and other for temperature.
For like the major sensors, it'll shut the engine down. But for some of the sensors, we'll cut your RPMs down, put you in reduction mode. So basically, you lose power to the engine and only keep you at a certain RPMs. But if it's an oil problem, more likely it'll cut the fuel pump and the engine just shuts down. Now, all sensors use a 5-volt reference. It's not a 12-volt. We'll explain that more.
That's later in the next class. But it's clear the sensors and the switches? Okay, you have switches to interrupt and sensor to send signals. Later, in other classes, we are going to use the sensor for millions of applications. With Professor Rodriguez, a lot of sensors in gasoline. With me, a lot of sensors in diesel. That's clear?
Which switch did you say it is that shuts
Temperature switch, coolant temperature switch, and the other one is oil pressure switch.
So which one turns off the engine? The temperature.
Switches will control the performance of the engine, either shut it down or put it in gear reduction.
Both of them combined?
Only the switch. The sensor is just a read, like your
No, I'm
gauge.
saying which switch shuts off the engine?
Well, if it's no oil, it'll definitely shut the engine down. It'll usually cut the power off the fuel pump. Temperature, depending on what temperature, depending on the model, and that's the thing, it depends. Sometimes you have computerized systems and sometimes you don't. With the computerized system, it'll cut your RPMs down and it'll eventually shut down if it gets any hotter to a certain degree.
Go ahead.
On the a.c.r, on the engine side, what is the output connect to?
Look, the one input from one alternator, other input from the other alternator, one output for battery bank number 1, and other output for battery bank number 2. Ready? Okay. Now we are going to connect the gauge. Oil pressure gauge, temperature gauge, and fuel gauge. When you talk about gauge, you are talking about gauge and sensor. The sensor is the element that sends the differential in pressure, the differential in temperature. The gauge is the instrument with the needle. And the cable to connect the sensor with the instrument is the sender or harness. You have the sensor, you have the gauge, and you have the harness or sender. It's clear, my friends? Sensor, gauge, and harness or sender. That's the nomenclature in the future, right? Okay, pay attention. All the gauge, follow me, papas. All the gauge, right. Kisses at the end of the class. Look, all the gauge, they have 3 elements, 3 terminals. One terminal is ignition, the other terminal is ground, and the other terminal is signal. Ignition, ground, and signal. Ignition, ground, and signal. Ignition, ground, and signal. All of them. Another one for the light on the instrument on top. for the light of the gauge.
Is that black ground or green ground, because it's in a case?
In this case, it's black.
It's black, okay.
It's black. All right.
And what color is the ignition wire?
Purple. Okay, for that reason, like Danny said, we are going to create here one ignition bus bar coming from the purple, and from the ignition bus bar, all the gauge they have the same. They have a ignition, they have a signal, and they have a
What do you want?
Ground.
ground. Sorry,
Ground.
It's been teaching too long.
sign.
Ran out of coffee.
All right, look at this. Ignition for tachometer. Ignition for oil pressure. Ignition for temperature. And ignition for fuel. Anybody follow me? All of them coming from ignition bus bar. What happens if this gauge is broken?
Yeah, they're still working.
My panel is out? No, the other ones are working because they are coming from the ignition bus bar.
In a parallel circuit.
Normally, the Mickey Mouse technician, they do this.
And you actually see this, it's still.
And what happened in that case? Finito. This is the most common, Jolly.
That is very common. Everything puts that in serious.
Hialeah.
When the first gauge goes out, it takes everything else out.
In Hialeah.
Yo, you doing this in serious?
No, that's how it was, but I changed it.
Hialeah.
One fused?
Huh?
Is each one fused?
Are they fused?
No.
In the ignition, no. No fuse. No fuse. All right, guys, pay attention. We are going to talk later about the sensors. There are sensors with 1 terminal, with 2 terminals, with 3 terminals, and 4 terminals. But in the class of diesel and gasoline, we are going to explain those sensors. Okay, the sensor produces the signal, and the signal enter here. From the body of the sensor, normally you connect the ground. From the body of the sensor. Each sensor have the same. One cable here for signal, and from the body of the sensor, ground. Look at the flow switch. You remember the flow switch? The flow switch, one terminal is ground, and on top is the signal. What is the color of the signal for fuel sensor?
Pink.
Pink. What is the color of the signal for temperature? For temperature? What is the color of the signal for oil? Light blue. No? Signal, signal, signal. And the middle ones, Lisa, are ground. And this is ground or negative. Ready?
Those should go to a bus bar.
To the negative bus bar. You like it?
Yeah.
You still have the Mickey Mouse wire on.
Look at this. What is the signal for the tachometer? Coming from? What color?
Dark gray.
Gray.
Noise.
No? Okay, guys. Okay. What about this? Excitation. And this is sense. What about the excitation? It's coming from?
Ignition bus bar.
What about this one? The positive. It's coming from the spine. You remember? From the start motor here. Now you have your boat. You can do the wiring of a small boat right now.
Yeah. 20 hours a week.
You can do the wiring or destroy the boat.
could you change because the ground on the sensors, that's because it's metallic, you have to use the ground, right? Could you make those green, or will it always
No,
black?
it is black.
It's black?
It's black. And let me explain something. Some tachometers, they have a selector with the letters 4, 6, and 8. Oh, yeah, Danny, can you explain that? Look at the flow switch.
This is your fuel tank. How it reads, fuel goes up. Does that work on voltage or resistance? Resistance, right? Most fuel senders are at 240 ohms. So all those gauges that you see for reading sensors, it's like having an ohm meter. That's all it is. It's just an ohm meter, medium resistance.
Okay, look at this. This is the signal entering here. You see? Signal, and this, signal, the white one, should be pink, and the other one is negative. And this is the case, metallic, connected to the bonding because it's metallic. You understand?
Yes.
Look.
Never positive.
Yeah, never put positive on it. Be like a time bomb.
That's clear? This one, negative. This one is the pink, and this is because it's metallic. Thank you, Danny. Nice.
Yeah, I figured that was a perfect example.
All right, guys, you are ready to start. The sea trail is at 2 p.m. The process to wire a boat is, for me, it's simple, but you need to go slow. You need to be organized. A lot of labels, a lot of electrical tape in different colors to identify cables, a lot of Sharpie to marks. At the end, the wiring should be perfect. The price of the boat depends on that.
Take pride. I'm telling you guys, make it nice, make it look pretty. The first one's not gonna be as pretty because it's your first one, but every time you do it, it's gonna get better and better. You'll understand better. Oh, I want to run it like this, I want to run it like that. You'll see. The first one, like I said,